Welcome to Maths for You channel. Past questions on pure mathematics from Oxford and Cambridge past paper. Use the trapezium rule with 4 strips, each of width 0.5 to estimate the value of integral 0 to 2 e to the power x squared dx. Giving our answer correct to 3 significant figures. And explain how the trapezium rule could be used to obtain a more accurate estimate. The trapezium rule gives us the estimate area. The integral is to use for find the area under the curve, but that gives you the accurate area. But the trapezium method, it gives you a close enough answer, so estimation. Let's start. As a sketch I put, and as a curve, just sort of rising up, and y equal to the x squared. And just 4 strips they asked us to use. From 0 to 2, 4 strips, each strip is 0.5, so 1, 2, 3, 4 strips. And the heights are from the H0, 1, 2, 3, 4, the height, and then just to find the area of the trapezium, it gives the estimated area under the curve. It's the answer for the integral of 0 to 2 x e to the power x squared dx, but not the exact answer, close enough. Give us 4 exact, normally so the integral will give you the exact value. So we need to find these 1, 2, 3, 4 trapeziums, and find an area of a trapezium. It's just half time parallel side, the addition of parallel side time the width, the height or the distance, perpendicular distance between the parallel side. Area 1 is half times 0.5 times H0 and H1. And that's are the parallel sides. And then number 2 is half times 0.5 times H1, H2. And the number 3, half times 0.5 times H2, H3. Number 4, half times 0.5 times H3, H4. It's a simple trapezium area. It's just half time the parallel side, the addition of parallel side, and the perpendicular distance. The area 0 to 2 e to the power x squared dx is area of trapezium 1, 2, 3, 4. So we have found these areas. Half times 0.5, H0 plus 2 H1 plus 2 H2 plus 2 H3 plus H4. We need to find this H0 to 4. So starting from H0, when x equals 0, H0 is e to the power 0. Anything to the power 0 is 1. So the first part is 1, and when x equal 0.5, H1 equal e to the power 0.1 squared. That is equal 1.284. Use the calculator. X equal 1, H2 equal e to the power 1 equal 2.718. And x equal 1.5, H3 e to the power 1.5 squared, which is 9.488. X equal 2, H4 e to the power of 2 squared, that is 4, e to the power of 4 is 54.598. So we have found H0 to H4. So simply substitute the values to find the areas, the trapezium 1, 2, 3, 4. So I have, if you look at it, H0 once and H4 once, H1, 2, 3 are twice. Just separate them. The first one is half times 0.5 times H0 plus H4 plus half times 0.5 time and then 2. 2 common out. Inside is h1 plus h2 plus h3. Then work it out, just substitute those values. Half times 0.5. The h0 is 1, h4 is 54.598, plus half times 0.5, that times 2. And h1, 2, 3, the value is already found. Just add those values, 13.49, and use a calculator. It gives you the 13.899 plus 6.745. Add them together, 20.644. The questionnaire asks us to give the three significant answer, so 20.6 square units. That's the answer. And the third part, to get the more accurate estimation, is narrow strips. So if you could use narrow strip rather than 0.5, if you could use 0.1, it has 20 strips and gives you more accurate estimation. Next one. The question is, in this question you must show detailed reasoning. Find the two real roots of the equation x to the power 4 minus 5 equals 4x squared. Give the roots in exact form. Okay. That's x to the power 4 minus 5 equals 4x squared. And bring that 4x to left hand side. That's x to the power 4 minus 4x squared minus 5 equals 0. There's a pattern develops here, just x to the power 4, x squared, and number. So we just separated x to the power 4 can be written as x squared minus 4x squared minus 5. So take x squared as a is a number or just notation. So a squared minus 4a plus minus 5 equals 0. That is a quadratic function or equation. So we can simply find that factors of that. That is AA, just a little cross AA minus 5 minus 1. And the factors are a minus 5 times a plus 1. Now we can actually replace a with x squared. So x squared minus 5 and x squared plus 1 equals 0. So x squared minus 5 is 0 and or x squared plus 1 is 0. That gives us imaginary roots. Well, all we've been asked to find the real roots. So x squared minus 5 equal 0. Then we can write this x squared minus 5 as x squared minus root 5 squared. This is like a squared minus b squared. That is equal a minus b times a plus b. So simply that's what I have done here. X squared minus 5 is x squared minus root 5 squared. So x minus root 5, x plus root 5. Then x equal root 5 minus root 5. These are the two real roots, even though 4 roots. And the rest of the 2 roots are imaginary. Okay, that's done. The next one, prove algebraically that n cubed plus 3n minus 1 is an odd for positive integers. Okay, let's take it. Right, the function of n cubed plus 3n minus 1. So we need to prove that the function is odd for all the values. So n equal positive integer. So n can be either even or odd. So just first I took n as an even. Even number normally represent with 2 letter. So I just took 2k, k is a positive integer. So if you could substitute that, f2k equal 2k to the power 3 plus 3 times 2k minus 1. That is 8k cubed plus 6k minus 1. And I have purposely written minus 1 as, so minus 1 equal minus 2 plus 1. That's what I did purposely to take 2 as a common. So this is what I did here. 8k cubed plus 6k minus 2 plus 1. Then 2 out from the first 3. So 4k cubed plus 3k minus 1 and plus 1. So 2 times anything is an even. So this is an even, plus 1. Therefore, f2k is an odd number. So now we need to prove it for odd. N is an odd. So if n is odd, again, normally we take a notation 2k plus 1. That's an odd. N is odd. So if you could use that 2k plus 1, 2k plus 1 to the power of 3 plus 3 times 2k plus 1 minus 1. So expanded, 2k plus 1 cube. So 2k cube plus 3 times 2k squared times 1 plus 3 times 2k times 1 squared plus 1 and 3 times 2 6k plus 3 minus 1. If you could simplify it, 2k cube is 8k cube plus 2k squared is 4k squared times 3, 12k squared. Plus 2 times 3 is 6k, plus 1, another 6k, plus 3 minus 1. The plus 3, 1, plus 1 minus 1 cancel out. What we have here is 8k cubed plus 12k squared plus 12k. I have separate that 3 as 2 plus 1. Then 2 common from all of them except the last one. So take 2 out. This is 4k cubed plus 6k squared plus 6k plus 1. So whatever inside, the 2 as a common outside. Therefore, that is even. And plus 1, so odd. So this function given is odd for all the values of the n, either odd value or even value. Next one. The equation of circle is x squared plus y squared plus 6x minus 2y minus 10 equals 0. Find the center and the radius of the circle. Find the coordinates of any point where the line y equal to x minus 1 meets the circle x squared plus y squared minus 6 plus 6x minus 2y minus 10 equals 0. Okay, let's do that. So the equation given, the circular equation given, x squared plus y squared minus plus 6x minus 2y minus 10. So I just wanted to make it as the complete square with x and y. So x squared plus 6x, we have x squared plus 6x. And or we need 9. So I just purposely add 9. So I add 9. And then again, we have y squared minus 2y. Y squared minus 2y. Then I have put 1. So we have add 1, 9 and 1, 10 extra. So just, we already got minus 10. So 10 extra, we have to take it out. That will be minus 20. Then x, now we can complete square. X squared plus 6x plus 9. Complete square is x plus 3 squared. Plus y squared minus 2y plus 1 is a complete square. Y minus 1 squared. And take the 20 to the other side of the equation is 20. Right, now it's just purposely written x plus 3, x minus 3 squared, plus to form the standard form, y minus 1 squared, and 20 is 4 times 5 is 20. So I just put 2 root 5 squared. So this is in the form of x minus here in the form of this one, x minus g squared plus y minus f squared equal r squared. So g and f are center and the r is radius. So if you compare this to the equation we have, the minus 3 and minus minus 3, and just 1 is the center, the coordinates of center. The radius is 2 root 5. That is done. And we have two, so line actually meets the circle. So we can actually substitute line equation into circle. So the circular line meet, substitute 2y equal 2x minus 3 into circle's equation. So which I did that. X squared plus, instead of y, 2 minus 3 squared plus 6x minus 2 instead of y, 2 minus x, 2 minus 3, 2x minus 3 minus 10. So if you could expand it, x squared. This one, 2x minus 3 squared, is 4x squared minus 12x plus 9. And then 6x minus 2 times 2 minus 4x minus plus 6 minus 10. This is 5 squared. 5 squared is 4x. 4 and 1 is 5 squared x. Minus 12y, and 6y is minus 6y. And minus 6x. Minus 12x plus 6x is minus 6x. And minus 4x is minus 10x. It's 9 plus 5, 15, minus 10 is 5. So what we have, 5x squared minus 10x plus 1. If I could divide both sides by 5, that gives us x squared minus 2x plus 1. That is simply, we can factorize it, which is x minus 1 is a complete square. X minus 1 squared equal 0. Therefore, x equal 1. Is only one value. And we find the y, the respect to y as well. Y equal 2 times 1 minus 3 is minus 1. So it's just one value when the circular line meets. So that means the line touches the circle at 1 and minus 1. That means that line is a tangent to the circle. Line, that's what we've been asked to say. What they say, so that can be reduced to part 1 about line y equal to x minus 1 and the circle. That is because of 1, it touches the circle, therefore the line is a tangent. Thank you. Please subscribe the channel and share the contents with friends and other fellow students. Thank you.